Hello, everyone. So this is just a trial discussion hour, just to see, that everybody is able to log on and participate. And we have to figure out the best way in which we can hold this discussion. Okay, so a few questions from my side. Have people been able to see the lecture notes? We have posted 3 lecture notes, and I posted just now one more lecture note, lecture number 4. Yeah, you can speak up. It's not necessary to, you can come in and use the audio.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
sir.
Yes, sir.
Yes, sir.
All right.
Yes.
Yes, sir.
So it's a little bit of a, problem in, for example, I have to sit at home and give these lectures to a blank wall. So in this discussion, at least, it's nice to see a few faces and hear the voices also.
Yes, sir.
This class is a large class. We have a registration of about 605 right now. And so obviously a discussion hour with 600 plus students is going to be very hard in terms of interactivity. So of course people, the purpose is that people can come in and ask questions, and we need to make it participative, but also you guys can also, I think it would be best, because you'll have a lot of questions regarding what we are learning. So if you can just scribble on a piece of paper, or MOOC allows you to post questions, but otherwise also, if you can scribble on a piece of paper, take a photograph and upload it and send it to me by email. So I can collect some of these queries that you have, and at least address some of them during the discussion hour. Right, so address them in the discussion hour, and of course we can take questions live and do that as well. Anybody has any comments so far? Would like to add? Any difficulties, anything? Okay, I'm going to share my screen with all right, can everybody see this slide?
Yes.
Yes.
Sir. Yes, sir.
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Yes, sir.
All right,
sir.
so it means slides
Yes, sir.
are visible. If a few people can see, I think others should also check it out if they're not able to see problems on their end. So this is one of the key slides that describe what this course is all about. How electronics enables us to solve problems. Any questions? Anybody who would like to clarify? So that's one figure to keep in mind as we go forward in this particular course. And the other one is, as we said, this is how we try to solve problems using electronics. And this is a general, can be a general problem solving methodology. Whichever domain you're working in, if you have a problem in that domain, and finding a direct solution is not that easy. And there may be another domain where things may be easier. So what you do is, it makes sense to transform the problem into domain 2, solve it here, and then retransform it back into a solution in your original domain. So the switching back and forth between two domains, taking advantage of another domain where things may be easy. So in this particular course, we are talking about that electronics, transforming problems into electronics problem can be beneficial. Not always, but considering the impact of electronics in a wide variety of situations, you should always be, whether you are an electrical engineer or not, you should always be on the lookout. It should be there at the back of your mind that perhaps you can use electronics to your advantage. But coming back, can somebody, so we talked about electronics, domain 2 could be electronics. We also said domain 2 is very commonly maths also. We transform problems into mathematical problems because it's easy to solve a mathematical problem. When you represent a problem in terms of symbols, you can manipulate symbols and equations, and you can do lots of deduction using maths and arrive at insights and solutions which you can use it back in whatever domain or problem that you're looking at. Would somebody like to give an example besides maths and electronics? A totally different situation where you have domain 1 and domain 2. You're working in domain 1 and you would like to go to domain 2, solve it here, and then come back here. Anybody who would like to give an example of domain 1 and domain 2? What could be domain 1 and what could be domain 2? By the way, I would like to add that the Zoom license that I'm using right now is for today's meeting is only 300 licenses. So a lot of people may face a problem in joining because the limitation is 300. But I just got a 1,000+ license. So from next time onwards, when we actually hold a discussion, it should not be a problem in 600 people joining and participating. But today, we've already touched 300 participants, so others may have difficulty in joining. So coming back, and all discussion are that we have, whatever we discuss, I'm going to try and record it and post it also, so that those who miss it for whatever reason, they have access to it, and whatever valuable is shared is available to everybody. So coming back, would somebody like to tell what could be a possible domain 1 and domain 2? It could be any field. It need not be, as I said, electronics and maths. It could be any domain, any two domains, domain 1 and domain 2. Yes? All right, so I can see people talking, but not audible.
So there are some answers in the chat.
Yeah, go ahead. Domain 1, domain 2.
So there are certain answers in the chat. You can have a look over there.
Chart. Which chart is there?
There is a chat box at the bottom, na?
Oh, chat box. Okay. Chat box. Let's see. I have to figure it out also. Chat here. Sir, kindly switch your voice chat as everyone would start saying something. Okay. Heat or light transfer. Language is a second domain used to, okay, good. Language is a second domain used to communicate one's thoughts. First domain is thoughts and language is the second domain. Very interesting. Domain 1 can't have physical lectures. Okay, then that's interesting. Online lectures. Okay, all right. That's good. Health problems using chemistry. Okay. Domain 1 small things clearly. Domain 2 microscope. All right. Very good. So really, so that's interesting. Yeah, so that's I use MATLAB to add an echo to a mono audio signal. Okay, all right, good. Terrain mapping for trajectory. Okay, so that gives me an idea that you guys got the idea of what we're trying to do. So you're seeing a wide variety of situations in which we are already employing this methodology of solving problems in another domain and coming back into the original domain. So that's good. Okay, so we saw what the goal of this particular course is. So these are the topics that we are looking at. 3 blocks: tools for circuit analysis, analog circuits, digital circuits. So the course has a very wide bandwidth, but despite that, there are many interesting things that somebody was asking, can we, in the diagram we showed sensors and actuators. Somebody was asking whether we'll do something about sensors and actuators. Unfortunately, no, because already the course has a very wide reach, and we'll have to limit it. Some sensors and some actuators maybe next semester when you actually come back to the campus, when you do the lab associated with it. So you may be handling some things there in the laboratory. These are the books that we said. Yeah, these are the books that are there. It's becoming sort of hard for me to monitor all the lots of chats that are going on. For me, for a single person to monitor, let's see. Okay, so let me finish sort of what I was intending to do. Let me see the chat part there. All right, winning the galaxy honestly and canceling the galaxy. Okay. This is, all right, so I guess people are really missing the campus, no? Okay, can you please upload the books on the portal? The books, I don't have right now any of these books that I've written. I have a hard copy actually lying in my office, hard copy of these books. I don't have the soft copy. I think Institute was trying to get soft copy. So let's see how this works out. And by the way, the lecture slides are more or less complete in themselves. They have all the information, and where books may be helpful is not so much in learning the theory, but as part of homework assignments and all that, we're only going to post every week, maybe somewhere between 5 to 10 problems. And many times students are looking for more problems. So books are useful from that perspective. And we'll see. As I said, Institute is trying to get the books. And which book should we prefer among all of them? Well, our course is structured in such a manner that there is no one single book which will cover. And also, the manner in which we will cover the topics is not covered anywhere else. The style and the manner, the way we will present different ideas is not covered in any of these books. These books are more like reference books. All the topics, for example, in lecture number 3, if I'm discussing about analysis of circuits, well, the techniques for analysis of circuits and all that can be found in this particular book here. Circuits, Devices and Systems by Ralph Smith, engineering circuit analysis by these group of people. They can be found there, but they will differ in the manner in which we present it and in which we use it. All right, so I'm not following any particular book as such. And as I said, the books that I've prescribed, they're all lying in my office, hard copy. So I'm sitting down and actually, the way I think these topics should be understood and presented, I'm doing that. So I'm not really taking anything from any of these books. But of course, these things are not new. Topic-wise, they can be found. All the material can be found in these books that are there. Yeah, Ankush has raised his hand, so go ahead. Here is where I'm sure all of you have lots of problems, lots of, I'm sure clarification. Yeah, Himanshu, somebody's raised the hand, so go ahead. Himanshu raised his hand, so. Quizzes, 20%, okay? Tutorial sections we are going to announce. We'll have tutorials on Friday. And tutorials will be held by different tutors. And tutorial sections would be smaller in the sense of maybe somewhere around 40 students or so per tutorial. So that can be more interactive. So exams, Gaurav Manwani has raised the hand. Okay, Gaurav.
Hello.
Yeah,
Am I audible?
Is that Gaurav?
Yes, sir.
Yeah, go ahead. Yes.
So could you please explain the tutorial structure, like the homework assignments we do not have to submit, but you said that you will pop some questions in the tutorial itself that we have to answer. So on what platform are we going to answer that?
Okay, so see, in all of this, we'll have to figure out what is the best way of doing it. Right now, the plan is, as I said, every week I'm going to post a homework assignment. And you're expected to try and solve the problems that are given there. And Friday is the tutorial at the same time, 6 to 7. So when you come for tutorial, when you join there, there'll be different tutorial sections. And the tutor is going to discuss the problems that were given in the homework assignment. And somewhere during the duration of the tutorial, not necessarily in the beginning or at the end or whatever, at some point, which we will make it uniform for all the sections, but at some point, the tutor would ask you would flash a problem on the screen, show a problem on the screen and give you about, let's say, it's a small problem related to the homework assignments, right? Small problem. So maybe you'll be given 5 to 10 minutes, let's say 10 minutes to solve the problem. And solving means, so all of you should have paper and pen with you. And so you should solve the problems on the paper. And, before the end of the tutorial, you should take a photograph of the paper and upload it and send it to your tutor or a TA. We'll send those information.
Via mail or on Mookit?
Via mail.
All right.
Via mail, send it to the TA's email address and the tutor's email address, all those will share. So you'll mail the photograph of your answer and mail it. So, okay, so what is your policy against unfair means during exam? So big problem is, maybe you guys can help. How do we find out unfair means? Right. So I don't, exams are important, but don't take them, there's a median line. Don't take them too seriously, neither too, in the long run. What is important is what you learn. And exams are more of a mirror, as I said, or they help you see how much you're learning. So we'll try and see. We expect all of you to be, we know all of you are honest. We expect you to honestly do it. And that's how you will learn. So I'm not going to go out of way and try all sorts of means to prevent cheating and all of that. I'm not, I'll trust all of you. And we'll follow the method that the institute recommends for conducting the sessions. This discussion hour is just, just a trial, just to try out things. We don't have a tutorial this Friday. Next tutorial, the tutorial will begin from next week. Okay, there's one more person, somebody raising hands. Anybody has a question to ask? The exams are likely to be, please note, I've written midterm exams, final exams. I think it would be easier on everybody, perhaps, if we hold not just one long exam, but have multiple exams spread over the semester. That would, I think, make things easier. So anyway, as I said, we'll try and figure out, all of us, how to go about. All these things have been posted. Okay, anybody has a question on this slide? Som wants to, yeah.
Hello.
Yeah, Som, go ahead.
Yes, sir. Am I audible?
Yes.
I wanted to ask that. I mean, you said the midsem and endsem exams can be converted to various multiple exams. That means later in the semester, the method of evaluation can be changed, right? Instead of midsem and endsem, they can be made into multiple continuous evaluations, or what?
So that's what I've written. If you wrote, I didn't write midsem exam. I wrote midsem exams. Right?
Okay.
Endsem exams. So what we'll do is we'll try, as I said, we'll have to learn along the way. And so midsem exam, for example, normally is, as you know, it's a 2-hour exam. And in a 2-hour exam, let's say we ask maybe, let's say 6 questions. So we may conduct a midsem exam consisting of 6 questions, maybe in perhaps units of 2 questions. So over 3 days. So it's like midsem A, B, C. On one day we'll have two questions.
Oh, okay, nice. Okay, thanks, sir.
Yeah, so that's what we'll see what is a convenient way of doing it. Because
sir,
remember, you'll have to work out on your own sheet. You have to take a photograph, you have to upload. So we don't want those files to become photographs and all that, somebody having difficulty with uploading. All those issues are there. Yeah, the
Okay, sir. That answers my
quizzes and
doubt.
all that will be announced. Quizzes will be announced, but let's see. Cheating, okay. So people are worried about cheating. Don't worry too much, okay. Focus on learning. Focus on learning. Can we have a trial quiz as well in order to get accustomed to the pattern? Sure. See, all the tutorials are like trial quizzes. Every tutorial you would solve a problem, you would upload it, it will be graded back, the marks will be shared with you. So that's there. Is grading relative? Well, the grading is just like you guys have already been there for a year in this institute, so it's going to be similar. Grading policy and all that. Well, take-home exams, all exams you guys are doing at home only. All exams are at home. And the take-home exams, if you're saying that give an exam and then work at your own leisure, so those kinds of exams have to be exams which are of a different nature. For example, I may ask you to design a system, and so those are harder to do. With 600 plus students, those are harder to do. How many quizzes? Well, the weightage for the quiz, as we said, was 2 quizzes. So we'll try to do something similar. The weightage that you're familiar with in the courses that you've taken before. But how we conduct, whether we conduct 2 quizzes, 1 and 2, or we conduct 4 quizzes, we'll see. We'll see what is convenient. Yeah, sure. I think somebody is asking, can we count best of 4 exams if 5 are? Yeah, we can do that. If somebody misses a quiz for some reason, doesn't do, sure. We'll do that. See, the goal is to make it as convenient as possible. Can you explain about mechanical calculator and what idea converted mechanical calculators to electronic calculator? See, mechanical calculator was using gears and levers and all that. They were also trying to, compute numbers, add numbers, multiply numbers. And those mechanical calculators were very primitive, but they were at least better than humans. Any long calculation, we are very poor at it. And especially, we make a lot of errors. So once you set up a machine, even with, let's say, gears and levers and all those, once you set up a machine, at least you get an accurate answer. You can learn more about it. I can share a link where you can learn more about a mechanical calculator. Homework assignment, as I said, assignment number 1 doesn't have to be submitted. There is no tutorial based on that particular homework assignment. So I'm going to post a solution maybe by Saturday or so. Right, so you should try out the homework assignment by that time. I would strongly advise all of you to solve the problem by yourself. It's very easy. In fact, it's very easy to deceive ourselves by listening to lectures and by looking at the solutions of the homework problems that we understand everything. It's only when you try to do it by yourself do you know that you realize whether you've understood and whether you can solve things by yourself. So please try it out by yourself. You guys already know you've done JEE, you've solved so many problems. Simply seeing the answers will not help you. Please try it out and then look at the answers. The quizzes, right now I cannot promise, most of them will be announced. And even if there's an unannounced quiz, let's say, I'm going to warn you that maybe in next 2 weeks, there'll be an unannounced quiz maybe. So it's a sort of announced, unannounced. Yes, you need to have calculators. Without that, you will not be able to solve many of the problems, or you'll take too much time. Quizzes will be in tutorial and discussion hour mostly, yes. Scientific calculator in laptop will do, yes. That should be good enough. But I would say, avoid having a laptop next to you. During quizzes and all that, we'll see a laptop will be a temptation for you to go back and look at all the notes and all the formulas. So keep laptops, keep your mobile phones away from yourself. Do the quizzes and all that honestly. I don't think it's asking for too much. The question paper will be on the laptop, right? Yeah, you could see you'll be joining on Zoom, so you could see it on your laptop or your mobile, whichever one. But what I mean is keep laptop and mobile aside for any other purpose except communication. Most problems I would want you to work out, not simply answer in terms of A, B, C, D, or multiple choice. Sure, we'll do multiple quizzes. Right, in what way do we need to submit the assignment? Assignment, as I said, you don't have to submit. Quizzes and homeworks, quizzes and tutorial solutions. You have to write it on a page, take a photograph and upload it. Okay, I think Som wants to talk, say something further. Anybody wants to? Anybody? Okay, this is a important slide also. The method of fabrication of, this is the reason, as I emphasize, why you find electronics almost everywhere. Where can we get details about our tutorial sections? We'll post it for you. We'll send you the details, your tutor name, your TA name, and then the tutor and the TA will get in touch with you. We'll announce it for you. We'll send it via email and also put it as an announcement on our platform. In lecture 3, you have not changed the current while passing through element. Can we also assume that current will not even pass through any element X? Current will not change if it passes through an element X. Well, when you have a fixed element X, let's say, and you apply a fixed voltage, then there's a definite current that will flow through it, right? So if you change the voltage, then the current would change. So it's vice versa. If you apply a voltage, then depending on the nature of the element X, a particular current will flow. If you apply a current, then depending on the nature of the element, a particular voltage will develop across the element. I had posed one question to all of you. For a resistor, we said, as all of you know, Ohm's law, voltage is equal to I times R. Voltage is proportional to current, and proportionality constant is a resistance. And as I said, the resistor does not have a memory. Ideal resistor does not have a memory, in the sense that the voltage the voltage at any point of time depends on the current at that instant of time. Whatever current has flown in the past or whatever, it doesn't matter. But do you think resistors do have a little bit of memory? That the voltage across a resistor does not depend only on the current flowing at that instant. It may depend on what has happened in the past. In what sense is a resistor also may have a memory? Ideal resistor, of course, no, but a real resistor may have a little bit of memory. That's good. Due to heating, why? You're absolutely right. So in the past, whatever has happened in the past, you've applied some voltage or current, and every voltage or current will result in some heat dissipation, and heat dissipation changes the resistance value. All resistors have temperature coefficient. Very good. Is it necessary? So you're right. So that's what is important to remember, that the elements that we handle when we say Ohm's law, V equal to IR, perhaps no resistor may actually obey an Ohm's law. It's only an ideal resistor. In practice, V may depend on more than the instantaneous value of I. No, so my point regarding memory in a resistor was, if it's an ideal resistor, obviously not. Voltage depends on instantaneous value of resistance. But I'm saying if I pick up a resistor in the lab, a practical resistor, and if I apply a voltage and I look at the current, will the current depend on the instantaneous value of voltage? The answer is not necessarily, because all that has happened in the past may have heated the resistor, and it would heat up the resistor, and it would cause some change. The issue is, if the change is very little, then the resistance is constant, then obviously there's no memory. So pointing out the differences between a theoretical concept and a practical device. A theoretical concept is always an abstraction. It's always a simplification of what is actually there. It will be only for a fraction of a second. Yeah, but fraction of a second, fine. Depending on how heat is generated and how heat is dissipated, temperature may. So please disable annotation permission to attend. This is very annoying. Okay. All right. So that's why this trial version is there. Annotation version, I'll have to see how to stop it. I'll show names of annotators. I'll see how to do that. Okay. No, so somebody said voltage will still depend on the instantaneous value of the current. But what has happened is our element has changed. The R value has changed, and the R value has changed a little because of heat dissipation. And the change in R value depends on the past values of the current. So in that sense, the present voltage is dependent not just on the present value of the current, but the past values of current also. So in that sense, we are saying that the resistor, because of heat generation, is modified, and the past values of signals or voltages that we have applied also modified. In that sense. Ensure you have from within your ensure you're starting from the bar located at the top of your screen. Click more. Okay, from the drop down, click disable attendee. Disable participants annotation. Okay. All right, fine. Thank you. I guess this should have done it. So, any further questions? So it would be better if you could write this answer in the forum. So like I don't got time to what you said. Okay. Okay. Attendance policy. We expect all of you to attend all of the lectures. I mean, listen to all of the lectures, of course. Attend all the tutorials and discussion hour. That's the attendance policy. If you're thinking of marks and all that, we'll see. Weightage, we'll see. I have also posted, from time to time, I'll post some supplementary lectures. For example, I've posted in the, a lecture, a PDF lecture of invention of the integrated circuits and the transistor. If you search on the YouTube, you can also find a video lecture by Jack Kilby when he got his Nobel Prize for invention of the IC. And I would suggest all of you to listen to that particular lecture where he describes how he invented, he was an engineer at Texas Instrument, how he invented the integrated circuit. So from time to time, I'll post some supplementary material. They are not essential to the course, but that will bring more, add more insight into our discussion. So I would strongly recommend that you look at it. How will we come to know that the attendance is done? Well, I have to figure out whether who all have attended. I think maybe I can keep a record. I'll have to see. If you watch lectures on YouTube, how will you come to know and then my attendance will count or not? Well, it's not for YouTube lectures. It's only for the live sessions that we will take attendance, right? For, let's say, for discussion and for tutorial. Tutorial anyway, all of you will have to upload the tutorial problem that we will ask you to solve. So that will serve as an attendance. Discussion hour is, we'll see. You're right, the resistor has changed as a result of heat. And you're right that the instantaneous value of voltage will depend on the instantaneous value of current and the instantaneous value of the resistor. In that sense, yes. But the relationship between voltage and current, so the point was if I pass a current through if I pick up a practical resistor in the lab, if I pass current through it, just by knowing the initial value of the resistor, and the present value of the current flowing through it, can I tell what is the voltage applied? The answer is no, because the value of the resistor has changed as a result of all the past values of the current that have passed through my resistor. So it's only in that sense, that we are talking about Akshay, please go ahead. Akshay Jain has raised his hand. Go ahead. Akshay, go ahead, unmute yourself and speak. No, we are, yeah, Akshay, go ahead.
Intention.
Okay, fine. Why are we concerned about the memory of a resistor? We are not. What I was trying to point out is the difference between a practical element and a real element. I mean, a ideal element. Ideal element, when we write V equal to IR, we take R as a constant, and we assume that the voltage is proportional to current, instantaneous value of current. In that sense, I was trying to point out, because the other components that you're familiar with, apart from a resistor, capacitor has a memory, and inductor also has a memory. So all that I was trying to, raise issues as to, because of the change in the resistance value due to heat dissipation, do you think resistor is memoryless? Memoryless. So sort of a provocative question just to provoke you into thinking about it. And it's good to see that, people realize that heat dissipation, heat generation and dissipation would sort of, affect there. I removed the thermal file from my phone and now it reaches 65 degrees during HDR plus extreme. Okay. Okay, so this was the last slide of our lecture number 3. So we are starting slowly with things that, slowly, I would say gently, with things that you're already familiar with, KVL, KSL, P to IR, P square over R, just maybe a year you looked at these things. So to remind everybody of the background that is, these are all background that we need to further the course, KVL, KCL equations and all that. Voice is not clear, okay. Audio is breaking, all right. So maybe what we'll do is, I think it's almost like 6, let's see. It's almost like 6:50, the duration of our discussion, 15 minutes. Maybe my headphone is giving a problem, so I need to check that. Voice lag. Okay, so I'm also getting this notice that low system resources may affect your audio quality by closing some application improvements. Oh, somebody asking, would we consider heating effects in resistors? Those are very important. Heating effects we always consider in resistors in practical space, especially in sensitive circuits. For example, you can switch on the video. Okay, good. So please stop sharing and better now. Okay. Because please write on chat. Hello? Is it better now?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir. Yes.
Okay, so I think what happened was my earbuds got discharged. So that's what. So those wireless earbuds, so those got discharged. I think that's why those issues were coming. The voice is better now? Okay, good. So we will close it. Any further? Will watching lectures in YouTube instead of MOOCit matter, as MOOCit will be used for gathering data? You are right. If you watch it in MOOCit, MOOCit has this analytics and all of those things. So that will give me some information on how, what the engagement of the class is with the lectures. So maybe watch it. I don't know. Is this memory is what we use in a practical life? Actually, good question. Do we use resistors as memories? We'll come back to when we discuss capacitors. We'll come back to this issue of memory. You know, all of you are carrying your cell phones with, you have your, some of you may have 4 GB RAM, 6 GB RAM, and all of that is there. We'll see how these RAMs are made. What is there inside RAMs? So MOOCit is our platform for you know, all course related. Please do not bypass MOOCit. I'm posting links for the YouTube lectures and PDF files only because I don't know whether everybody is able to access MOOCit or not. So that's why I'm sending it through email also, and I'm posting it on MOOCit also. What kind of analytics is shown by MOOCit? Well, I'll have to learn. I'll have to find out what all. I tried it. See, it has not gathered enough information till now. So it didn't show me anything when I looked at it yesterday. But I'm sure it shows something similar to what YouTube does. Yeah, probably. Number of videos you've seen, number of slides downloaded, all those things, yes. Okay. Any sir, have a look at my question, please. Which question is it? Ashish Kumar, what is your question? If we take two identical resistors, take the first resistor through various steps, finally bring the state of the first resistor to the same state as that of the second. Are we saying that both have different resistances now? So that's where you're making it different. You're saying the same state, meaning current and temperature. When we are talking about a resistor, we are saying two resistors with different histories, two identical resistors, let's say, but they have different histories. And we apply the same voltage to both of them. Well, they may have different currents because of different history. Their resistances would have changed, and therefore they will have different current. But if you say that the current is the voltage applied to a resistor is the same, its temperature is also the same, then of course that. Huh? So I think don't get too, this was only a side discussion in terms of, so the idea was things that you think are constant, resistance is a constant, is not really a constant. It changes, right? And it changes not just due to the heat. The other thing that we, many times we forget that all components have a lifetime and all components degrade with time. So, everything has a certain life. So if you take a resistor, its value may change, all the heat and everything that dissipates in the resistor over time, that heat and all that may cause degradation in the material may change, and thereby the resistance value also changes. So things are, not really constant. They do change with time. So this was just to, sort of, discuss, bring some practicality to some of the ideal elements that we look at. That's all. Okay, so I'm going to stop this. We're done with 50 minutes. Learned a few things, and hopefully next time, I'm sorry because we did this today with only 300 licenses. Next time we'll do it with a full set of licenses, and we should not have any difficulty in everybody joining. And chat is a good, so I'm learning, so at least I can follow and see what people are raising. In real engineering, do we consider all these things in a register? Yes, we do. And let me give you a very, while leaving, give you an example. In most of your digital thermometers, for measuring your body temperature, we use an element, in many of them at least, we use an element called thermistor. So it's a resistor which changes its value depending on the temperature. And so to transform a resistor into a temperature, what we may do is pass a current through this resistor and measure the voltage. And from that voltage value, extract the value of the temperature. Now, it's important that the current that you pass through the thermistor doesn't heat it up and modify its value, because we are trying to use the thermistor to measure the ambient temperature. And if you pass current through the thermistor to measure its resistance, well, you must pass very small amounts of current and ensure that it doesn't heat up the resistor. So these things are important. And in fact, when you come to the lab, you will see that you can find let's say 100 ohm resistors with different power rating. So a 100 ohm resistor with, let's say, a half a watt rating or a 1 watt rating. So resistors are also made and sold with a rating besides the resistance rating. They're also sold with the power rating. So if you use a resistor with, that's not capable of dissipating, let's say 1 watts of power, and if you try to, pass a current such that 1 watt of power is dissipated, well, that resistor may burn out. All right. Okay. So let's close this particular session, and so we'll meet next Wednesday. And in the meantime, I'll be posting more of the notes, and and of course the forum is also there for you to Mookit forum is also there for you to discuss these things. Okay, so if no further question, shall we all close? Okay, thank you all.